So when we're talking about the ITCZ, if we zoom into that area, what we're seeing is that at the surface, we've got this convergence of air coming from the north and the south. When you have convergence of air, the air has to rise up because it can't go anywhere else. And as it rises up, the air will cool and eventually condense into droplets and form clouds. And we saw that in the satellite images. We have this band of clouds going all the way around the planet. And we have lots of rainfall. And actually, that's why we have the rainforests in the tropical regions, because of the ITCZ, which in some places we're getting rainfall nearly every day. So this air will keep on going through the clouds. Eventually, the air will come out of the top of the clouds. And then it reaches a layer in the atmosphere we call the stratosphere, which is like a lid. The air can't go any higher, and so it has to move again north and south. By the way, the air which comes out of these clouds because we have a lot of rainfall, is very dry. All the water has been taken out by the rainfall. So the air which is coming out, firstly, is much colder because it cools as it rises, but it's also very dry. This air starts to move north and south. But again, we have Coriolis force. The air which is going to the north will be bent to the right of the direction of its motion. The air going to the south will be bent left of the direction of the motion. And by the time it reaches about 30 degrees north and south, the winds will be more or less parallel to the latitude. So the winds don't go any further than 30 degrees north and south, and then they start to sink. And as they sink, the air starts to compress because we have highest pressures at the surface. And as you compress air, it starts to warm up. So this air which is sinking, you can see the colors are changing in this plot, start to get warmer and warmer. They started out being very dry because they don't have any moisture up above the clouds. So when this air gets to the surface at 30 degrees north and south, it's very hot and very dry. And this air is moving down, so it actually doesn't allow for clouds to form. So it turns out that these are the areas where we have the deserts around the globe. We'll see a map in a minute or so. But this produces the Hadley cell. Maybe I'll go back one. This produces the Hadley cell, which goes between the zero, the equator, or the ITCZ, and 30 degrees north and south. We showed before that if we don't have any rotation of the planet, this Hadley cell will go all the way to the poles, from 0 to 90 degrees. But because we have the rotation of the planet, the Hadley cell only goes to 30 degrees. So this Hadley cell, in reality, is only from 0 to 30 degrees. And we don't always see two of them like we see in this image. And here you can see an animation then of the monthly rainfall in the tropics. On the right, you can see the Hadley cell. Sometimes we have one Hadley cell. Sometimes we have two Hadley cells. It really depends on the season and where we have the maximum heating by the sun at the surface. During July, the rising part of the Hadley cell will be in the northern hemisphere where it's hottest and will sink in the southern hemisphere. In January, it'll be the opposite. And in April, May, and September, we'll see two cells which will start in the equator and will sink in north and south of the equator. Where we have the rising branch, that's where we have the rainfall. And so the rainfall is also migrating north and south of the equator with the migration of the Hadley cell. So as I mentioned, in the tropics where we have the rising air, this is where we have our rainforests around the planet. It rains every day in the Amazon jungle, rains every day basically in the Congo and in Southeast Asia. So it's very moist, lots of rainfall. This is the rising branch of the Hadley cell. But where it's sinking at 30 degrees north and south, that's where we have all of our deserts. The Sahara Desert, the Kalahari in the south, Australia. You can see on the map here, most of the dry deserts occur more or less around 30 degrees north and south. And if we look at the rainfall then, this is the monthly progression of the rainfall. The color, the blue scale is the amount of rainfall on a monthly scale. And you can see this goes up to about 400, 500 millimeters a month. For reference, in Tel Aviv, our annual rainfall is 500 millimeters for the whole year. So here you can see in the tropics, they're getting our annual rainfall basically every month. So we can see this band going around the planet where we have lots of rainfall in the tropical regions. And on either side, you have the very light blue, which is basically no rainfall or very little rainfall, and that's the Hadley cell, where we have the subsidence, the sinking motion of the Hadley cell, 30 degrees north, 30 degrees south, where we have very little rainfall. There is some variation according to longitude, and we'll talk about that in the next lesson.